Good morning. We are going to start now. Show me a thumbs up if you are ready. Good. Good morning again and welcome everyone to this tutorial, distributed and asynchronous task queues using Python Celery. Okay. Here is how I am planning to conduct this tutorial. The overall duration will be approximately 3 hours, few minutes here and there. We are going to take a break in between, 20 minutes or so. I am going to cover Celery basics as well as advanced topics. You can take. Okay, so we'll cover basics and advanced. So what is the meaning of basics? When I say basics, it means that it will be good enough for you to say that you know what Celery is, where you can make use of it, and how to write code in Celery. When I talk about advanced, it means that it will be good enough for you to say you know how to write production level code in Celery. So we are going to cover both the topics. Okay. Start with a short introduction of mine. My name is Daksh Gupta. I am a software product development consultant. I'm proud to say that I am writing code for more than 23 odd years. I have written production code in Python as well as in 6 other programming languages. So I started my career long back in a startup. I'm sure the term startup was not cool back then, okay, but turns out to be the best decision of my life. I worked for a very long time in Symbian, so if some of you are old enough to have used Nokia N series phones, or maybe your parents might have, so anytime you checked your email or browsed anything on those phones, all those packets went through the code written by me. After that, I worked for Nokia Networks, the telecom infrastructure, the eNode Bs and base stations software. Okay, I do create blogs and vlogs occasionally in Medium and YouTube. Okay, okay. So let's start with a general use case, and I'll start with a problem statement. And before I get into that, let me ask you a question. What, in your opinion, is the major problem we have in software development? I know it's a bit subjective and we'll have multiple correct answers, but I just want to know your perspective. What, in your opinion, you think is the major problem in software development? Anyone? All answer will be correct. Yep. Too much dependency. Yep. That's right. Other things? Building up technical debt over time. That's right. Yes. Horizontal scaling. Good one. Yep.
I mean, I work in data science, so processing really big data.
Processing related data. Yeah, all those things are actually valid. But let me give you some another perspective. We have a problem of plenty in software. We have more solutions out there. So the way we do software development today is that we have the solution, we take our problems and fit into the solution. So pretty much you go to any organization, you have programming languages, tech stack, frameworks, libraries, pretty much everything is decided in advance. And you need to plug in your problem in that. Okay. Instead of other way around, where you understand your problem and find the appropriate solution. Okay. So as a software developer, the best advice I can give is to understand your problem. Okay. It's not that I need to write code in some framework library, just start doing that. No, understand your problem first. That's the best thing you can do as a software developer. That's why I started with a problem statement. I'm going to show you a use case, and throughout this tutorial, we are going to write code based on that use case. And it's a simple use case of our banking system. All of us have bank accounts, right? And whenever any transaction happens in our bank account, we get a notification, maybe SMS or other email notifications. All of us get that, right? Show me a thumbs up. Okay. So assume some company has written a banking operating system for us, which takes care of all this online banking and whatever we do online with the banks. But there is one thing that is missing, and that missing thing is notification. Let's consider SMS notifications. Okay. We have to implement SMS notification system for our customers. That is not there in banking operating system, and we have to implement that. Now here comes the question. There are two distinct things, banking operating system and SMS notification system. Okay. Sorry. Do you think the banking operating system needs to be closely integrated with SMS notification system? No. In general, no. Okay. May I know why? They don't need to be tightly coupled. Sure. Okay. So I will show you two flow charts of implementing this particular notification system. You have to look at this a bit carefully, and you have to tell me which one you think is better. In the BOS one, we have SMS notification enabled. Top, first few steps are same in both BOS 1 and 2. I hope you can see this. Okay, you can see this. Possible to shift. If you are not able to see this, it's possible for you to shift. Yeah.
It's far away from over here. It's hard to see.
Okay. Okay, we'll share this after the tutorial anyway. And in BOS 2, we write the transaction logs that somebody deposited money, somebody has taken some money out of your bank account, and there is a separate entity called, let's call it as notification service, that sends the SMS. So all of you, I think most probably will say that BOS 2 is better, right? How many of you think BOS 2 is better than BOS 1? Raise your hands. Okay, good. How many of you think BOS 1 is better? Okay. The banking operating system need not to be dependent on SMS notification system, because these two are totally separate entities. Okay, they have no relation with each other, and in all probability you can create your own banking operating system, but to send a SMS you need to maybe use a third party software or library. You do not want to integrate that, right? Also, the problem statement today was we need to send SMS. Who knows, tomorrow some premium customer, we need to send WhatsApp, we need to send DMs, or many other things. We may even send a person if that is a super premium customer. Okay, so any change you do in your notification service, there is no need to do regression testing of your banking operating system. Make sense? Yes. So these two things has to be separate, and when you get into situations like these, you create what we call it as task queues. Now look at this picture over here. In here, the banking operating system does the transaction, logs the transaction, and completes the transaction. A separate service called notification client in this particular picture is taking the transaction logs and sending those logs in a task queue. And this notification service on the right hand side of your screen is taking the tasks from the task queues and sending the SMS. Okay. So in situations like these, we use Python Celery. Okay. Now here comes another question for all of you. Look at this picture, and if I say that why on earth we are making it so complex? Why can't notification service directly looks into transaction logs database and sends the SMS? Pretty much the same thing, right? Security vulnerability is one. Yep, that is there, security vulnerability. And any other reasons somebody can tell me? Correct, absolutely right. So security is one aspect. The second aspect is that when you expand your services at the transaction layer, like notification service for SMS, then WhatsApp, then direct messages, everything doesn't need to look into the transaction DB logs. And anyway, transaction logs are having much more things than just the details whom to send the SMS. Okay, so whenever you have to create a task queue, okay, you use Python Celery. So you are creating a system where there are two distinct systems out there connected via task queues, and if you have to do something similar, you use Python Celery. The concept of task queues are okay to all of you? Show me a thumbs up. Okay. Now my question is Python Celery is the only software which can do this? Yes or no? Obviously not. There are hundreds of open source solutions out there, and maybe hundreds of proprietary solutions out there which are doing the same thing. Okay? And as I said in the beginning, we need to understand the problem before taking a solution out here and using it. So I am not telling you over here which is better, because better is based on the context of your problem. It's not based on which software is actually better. You cannot say a software is better without any context of the problem statement. But since this tutorial is about Celery, I have to tell you two things which can help you to take an informed decision. First thing is that Celery is pure Python. If you are working in a Python ecosystem, your teams are aware of Python, they are very good at it, and they are very comfortable, you can just make use of Celery. It's pure Python, you don't have to go to any other programming language. Okay. Now with this particular statement there comes a question. So these things you may or may not have used it, but all of these softwares have their Python clients also. Kafka has a Python client, RabbitMQ has a Python client. Why can't I go ahead and use Python client of something else? Then it will still be Python ecosystem. I'll have to write code in Python. I don't have to deviate from it. Why don't I do that? Why I said that if you are using Python, use Celery, not others. Any guesses? Each one of them has Python clients. Sorry? Swap one out further. Yep. So I can tell you one thing. It may not be 100% true, but most of the time, when you are using a framework, library, or any other software, the best way to use that comes from the language in which the framework is or the software is written. For example, I can tell you my own case. Apache Kafka is written in Java. I started with a Python client. I used a lot, but when I intend to use complete functionality of Apache Kafka, I had to move from Python to Java, because when you look into streaming protocols and making sure you are handling streaming in the best possible way and making use of all the facilities that Apache Kafka has to offer, it was not possible in Python with Python clients. It's good to understanding, learning, making a hello world program, but if you want to really make use of the complex part of the system, the best way to use it in the language the software is written. If you go to the page of any Apache software product, it may support multiple languages, but there will be some features where it says that not supported in X or Y language, right? That's why Python Celery comes into picture, because it doesn't have these constraints. Okay. Now the second thing is that if you want to do some prototype, and if you want to have some proof of concept, you want to show it to your customers or your stakeholders, in that case you can do it fast. With Python Celery you can Python Celery may be the fastest way of implementing these kind of task queues. Okay? So, these are the two things you must remember about Python Celery, so that you can take an informed decision. So, task queues are clear till now? Yep. Okay. Now, task queues can be deployed in two ways. Okay. We can create multiple task queues in a single system. Okay. That's called standalone mode, and we have multiple task queues in different systems. It's called cluster mode. Okay. That's usual definition for pretty much everything. So, what was the topic of our tutorial? Distributed and async task queues, right? We know task queues. Task queues are clear, right? How it will be distributed? We have multiple task queues. It can be in the same machine or in multiple machines, right? It will be distributed. So, the items that are inserted into the task, for example, sending the SMS, it is synchronous or asynchronous? Asynchronous, right? Yes, because if you are not waiting for SMS to be sent before completing your transaction, that's asynchronous. So, that's the title of this particular tutorial, distributed and asynchronous task queues using Python Celery. Okay. And these task queues again can be used in two scenarios. Scenario number one, when you have no hard real time requirements. So, what is a real time requirement? What is the meaning of real time? Okay, so real time in software, there is nothing known as real time. Real time is all about what is your tolerance level. If you want your banking transaction to be written in 10 milliseconds, and if it happens, it's real time. You are having a telephonic conversation via satellite, half a second delay, but still it will be called real time, because based on the tolerance level, we call it real time. So, if you do not have a hard real time requirements, you can use task queues. And second thing is, when you want to make use of multiple CPUs that are spread across your system, for example, data science, right? You got, let's talk about some data analytic like fraud detection of the banking transaction. When we get that, one machine will look into the transaction log, and it has to determine whether this is a fraud or not. Irrespective of what kind of machines we have, the CPU will not be good enough to do it in near real time. Okay? And we want to make sure that we do some kind of map reduce, and we can make use of other systems that are out there, other CPUs that are out there. We can use these task queues. So, these are the two scenarios you will create a task queue. Okay. Any queries till now? Okay. So, before we go to the code, one last thing. The task queues in Celery is not created by Celery, it is managed by a message broker, and the most prominently used message brokers are RabbitMQ and Redis. Okay. Redis is a DB and RabbitMQ is AQMP implementation. In this tutorial, we are going to look into RabbitMQ for most of the exercises. We will also have one Redis exercise just to make it complete. Okay. So, here is how your Python system, any system which is using Celery, will look like. On the left hand side, you will be having some Python files which will be sending tasks to task queues. These can be called producers of the task. On the right hand side, you will have a Celery system which can work on those tasks, for example, sending the SMS. These can be called consumer side, but producer consumer is not something that is used widely with Celery because it's more about tasks. I am doing some tasks, Celery is a task queue. But if you just use RabbitMQ, maybe you will see producers and consumers a lot more. So you will have two set of files. One is Python files which are sending tasks to the task queue, and another file is the Python file which is taking the task from the RabbitMQ task queue and implementing the task or working on that task. So this is how it looks like. Okay. So before we move to the code, any queries? Okay, I have shared a prerequisite documents with all of you. So is it working in your systems? Okay. So in case if it is not working in some of your system, maybe I can request you to just pair up with the person next to you, okay, so that it will be helpful. Okay. So Celery, as I said, it's pure Python. I'm just briefly going through the prerequisite. Okay, the Python version and Celery should be in your system. We need to implement RabbitMQ, but I'm using Docker for RabbitMQ. So let me run RabbitMQ. And to check whether RabbitMQ is running or not, you can go to localhost 15672 port number, give username password as guest, and if you see this particular screen, your RabbitMQ system is working. Okay. So that's pretty much the start of this particular coding exercises. You just need to make sure RabbitMQ is the only external thing which you need to make it up and running. Okay. Okay. So in all the folders I have shared with all of you, there are only 3 files, same name file. One is banking.py, which is just a dummy implementation of depositing some money in your bank account or withdrawing money from your bank account. So you can see this banking.py file, and there is task1.py. This is the Celery task implementation. I'll go through it in detail, but I'm just telling you the file. There will only be 3 files in all the exercises, just that contents of these 3 files will change in due course. Okay. So here what I am trying to do is that I'm actually solving my problem statement. I want the SMS notification to be sent to my customers, but SMS is not sent by my banking operating system, which is this banking.py. I am using some another system which takes the data and just puts into the task queue, and this Celery takes it and sends the SMS. That's the simplest possible use case on which we are going to work. So if you go to your folder basic uses, there is a folder name 1. In 1, this is the code that is written. Okay. So you can see this folder structure. We have banking.py files. You guys can see the code, or shall I increase the font a bit? It's better. Okay. Entry point is the main function. Okay, I like to call it as entry point instead of main. Okay, and task 1 is our Celery task. Okay, now just look at this particular code, and if I call this entry point function, what will happen? You can see that the message is printed that this much amount of money is deposited in your account and sending SMS, and SMS being sent as your account has been credited with $5,000. Now in this case we used inlined. Okay, we haven't used Celery, we haven't used RabbitMQ. This is just the inline way, and we are going to convert this into Celery way of working, right? So if you are writing a banking software integrated with SMS notification system, this is how you are going to write. So what all things that needs to change over here? Okay. In this entry point function, you can see task send SMS. Who I want to send SMS? I mean, which software I want SMS? Sorry. So in the example earlier, we said that there will be different set of services which are going to send SMS, right? So instead of calling this task send SMS immediately, we need to put this particular task in the task queue, and Celery is going to pick up that task. Okay. So here is how your first Celery, pure Celery program will look like. So in the folder structure, if you go to folder number 2, this is the code that will be written. So you are actually importing the Celery and creating the Celery instance. Okay. In the broker, I am giving my local host RabbitMQ. In the reality, you are going to make use of some IP address where you are running the RabbitMQ. So in Celery, I am saying what is the name of the Celery module, what is the backend, what is the broker. Okay. And in the SMS function, I am adding a decorator called app.task. This is the decorator I am adding. And in the SMS task send SMS, I am saying delay. Okay. So here is how you are going to make use of Celery. When you have to put a task in a task queue, instead of calling that in line, you say function.delay. No change in the way you are passing the parameter or anything. Instead of calling that function directly, you say function.delay. Okay. And that's all you have to do. If you call those functions inline, it will be executed immediately. If you call delay, it will put the task in a task queue, and that task queue will be executed by Celery. It's clear? Okay. So actually the structure of program doesn't changes a lot even when you use Celery. It's just that you need to make sure you are putting task in a task queue, you are not calling that task. If I don't put delay over here, what will happen? The SMS function will be executed here itself immediately. If I saying delay, it automatically takes care of putting this particular task into a task queue. So we will see this example number 2 in the basic uses. The entry point function, you can see there is a delay over here, and in the task 1, okay, we have app.task, a decorator, and I am saying my Celery backend I will come in some time. Let's assume, let's understand the broker. Okay. So broker, I am giving the address of my local machine. In reality, you are going to give username, password to a particular IP address. Okay. So this is the only change you need to do to make your Celery up and running. Okay. Now, to start Celery, here is what you need to do. You are in folder 2, basic uses. You call Celery, give the name of the module and say worker. So in Windows, if Celery is directly not working, you have to say Python -m Celery, and rest of the command will be same. Okay. This is the command. Is it working for most of you? Sure. So in the task 1 file, the files are already there. In the exercise link I have shared, the files are already there. So here what we are saying that this task send SMS is a task which will be implemented by Celery, not by the calling program. Okay. So calling program is saying delay. Delay means put this particular task in the task queue. Okay. So is it working for you? This one, this command. Okay, let me. Again, if you are using Windows, you need to say Python -m, then the same command. Okay, good. Working? Okay. That's the basic that has to work. Okay. Now what will happen is that when I run my entry point function, so it is printing only depositing 5,000 to account 1, 2, 3, 4, 5, 6, nothing else. But sending SMS will be printed at the Celery console. Sure. So assume this is our program and I am not calling delay. Okay. I am just calling task send SMS. That means I want to send SMS. If I run this, the sending SMS will happen here itself because the function is called in the context of our program, our main program, right? So it doesn't know that it has to put something in the task queue, right? To make it understand that, you have to put this task in the task queue. You say delay dot delay. That's all. If you say dot delay, then the sending SMS will not be printed over here. It will be printed in your Celery console. So prerequisite, RabbitMQ must be working in your system, and you can, in short, you can directly use app with broker and backend. Even you can leave backend empty for now. We'll talk about backend in a moment. Make sure your broker is, even if you just give PyAMQP, it will consider it as localhost. Otherwise, you can give username, password, guest at localhost. Which command? This one? Visual Studio Code. Okay, yeah. So if you take the code and change it just by adding delay over there, it should work. Sure. Let's remove logs. Just use this. Celery -a, task 1 is the name of our module, and worker. That's all.
So, picture here, you have two processes.
Yes.
One is started by the Celery command,
Yes.
and then the other one is just you running Python -employee.
Right.
And because that function was decorated with the app.task,
Right.
it created a delay attribute that you call on your sending side. Okay. So what this means is you're going to have one code base for both the sending and receiving aspects.
Okay, most of what you said is correct. Slight difference. So the question is that whether the code base is same or different for sending or receiving side. So when you implement Celery, you are just implementing receiving side. Like sending SMS, you are implementing at the receiving end. While in sending end, you are calling that function not like normal Python modules. You are calling it with an attribute called delay, which means Celery will take care of putting that particular function into the task queue so that it gets executed on the another process. If you call that function directly task send SMS, it will be executed there just like any other Python module. So the implementation is one. Task send SMS is the implementation, that is one. It's implemented at the Celery task level. You are calling that in your client program. You can call that inline as if you are calling any other Python module function, or you can call it with delay. Delay will take care of putting this particular task, not calling it in the client process, client Python code. It will put that into RabbitMQ, and RabbitMQ will give it to Celery task, and it will be executed over there. Okay.
And the reason all that happens is because your call is in Celery.
Yes.
Over here. And so instead of running Python, blah, 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 you're running on Celery. So any of the non-decorated functions that you just run as usual, anything that you have the decorator is putting into the queue.
Yes.
Right? And
okay. So anything with the decorator, it will look for that in the queue. It will not put into the queue from the Celery. It will put into the queue from the Python clients. Okay. So this command is working for all of you? No?
What is the result when you do that again?
It will just wait.
Okay.
Okay.
I thought you got the message that you read it.
Yeah. So if you run your client, you should get the message. So if I run this client entry point, as many times I run it, as many times I should get the message of sending SMS.
Is that that's the Celery worker log?
Yes, that's the Celery worker log.
So I see the message received, but I don't see the actual print statement created here.
it's different in Windows. You have to add a --pool equals
Solo.
Got it.
Okay. I wanted to touch it, in some later point of time, but there is a difference between Celery implementation in Linux or Mac or Windows. Actually, Windows doesn't support forking of the process, which Celery does. Okay, Windows supports spawning of the process. So that's the difference, because of which there is a problem in running it in Windows or in Linux as compared to running it in the Linux. So basically there are three ways you can make use of it. Let me show the Windows part. Here is how you can do it. Can you see the command? In your Windows system, since it has a different way of forking the process, you will have to use this. Okay. Is it running now? Because that's the first exercise. Show me a thumbs up for how many people it's running. Okay, not running. Okay. For the people, if it is not running even after some effort, may I please request you to share your screen with somebody sitting next to you. Maybe during the break I can come to you and help you to make it run. Is that okay? Okay. Okay, so you understood the basic picture, right? How it is working. Okay, so you have a Python client. You can have multiple Python clients with you. Just call the delay in the task. It will put automatically in the RabbitMQ, and it will be executed in the Celery workers. Now, anyway, we are talking about pool is equal to solo. Let's talk about the basic thing which Celery provides is Celery workers. So, how many of you know about GIL in Python? Everyone, right? What is that? Global interpreter lock. What it does? Annoys you. Yes. Okay, what it does? It prevents multi-threading, right? Real multi-threading. Because at any point of time, no matter how many cores you have in your system, it will not be purely multi-threading where multiple cores are actually executing simultaneously all the time. But Celery is Python, so Celery should also have this GIL related problem, right? Yes or no? You should, right? But it handles it. Okay. Let me tell you how. Okay, so we are going to chapter 2, parallel processing with Celery. So if you go to your chapter 2, the code which I shared, okay. So by default, Celery is concurrency enabled, and it creates multiple workers simultaneously. Every time you say Celery minus a, your task 1 worker, it creates multiple workers simultaneously. Okay, let me show you. So I am going to chapter number 2, 1. I am going to do that right now. Okay. So I am again starting Celery. Look here, I am starting Celery minus a task 1 worker, some different set of command with Windows. Okay. Let me put a htop in my system, and let me filter it with Celery. How many instances of Celery worker you see over here? Now, how many instances of Celery worker you see over here? 10ish. Okay. So you can see the first one is the actual Celery which we called, and it has actually forked 10 workers for us. And how many cores I have in my system? You can see on the top I have 10 cores, 0 to 9. Okay. By default, in Linux or Mac environment, if you start Celery worker, it will automatically fork number of workers which are equivalent to number of cores in your system. You don't have to do anything. So if you have 10 cores, 20 cores, it will spawn that many workers for you. You can see that if any one of you have Linux, you can see it with top, or Mac with htop. You can see as soon as you create a Celery worker, see, we haven't changed any command, right? We are just calling Celery the way we call it, and the number of workers are there up and running. So it actually multi-processing enabled. So 10 cores, 10 workers, all 10 can be engaged at any point of time. Make sense? So the point which I want to make over here is that it's easy. You are not worried about changing a hell lot of code. You are not worried about multiprocessing. Just do it. Even if you do the basics of Celery, it's fine. It will take care of most of the scenarios.
So what if you grep for to see those processes?
Sorry?
What if you grep for to see those processes?
Celery.
Oh, the Celery. Okay.
Yes. You can filter it with Celery.
Why do you need RabbitMQ? Can't you just submit the task to Celery directly?
You can, but Celery has to keep it somewhere because it cannot execute it at that point of time. So that part is task queue. Okay. So Celery cannot guarantee that as soon as you put a task, it will be executed, which means it will be in hold position at some place. So instead of implementing something like task queue in the Celery itself, they used RabbitMQ, which is well known and tested and works perfectly as a task queue. Okay. Did I answer your question? Yeah, okay, thank you. So here, look at the big picture. You have task queues when you want two different systems to work on something, right? Where one will act as a producer and another will act as a consumer. And you do it via RabbitMQ. Because RabbitMQ, when you put the task in the RabbitMQ, it will be there. Okay? Let me show you. I have stopped my worker. Okay? My worker is not running. You can see in my stop. My worker is not running right now. So what will happen if I go ahead and call my client? My worker, Celery worker is not running. Call my client. It is not showing me any error. It is saying, okay, deposit 5,000 in account 1234. And when I start my Celery worker again, because the tasks are in task queue now. Okay. So if I start it again, should be able to take those tasks and should be able to do it, like sending SMS, sending WhatsApp. So that's the answer to your question. So Celery may not be running all the time. If you implement it in Celery, it will not be running all the time. But if it's RabbitMQ, even if your Celery goes out of the picture, it will be there in the RabbitMQ. When Celery comes up, it will take your task and execute it. This SMS notification, what will happen if we do not get it within 1 or 2 minutes? We generally get it within 10-20 seconds or so, right? In general, on an average. What will happen if you don't get it, let's say, for 2 minutes? Nothing, right? I'm getting a delayed SMS, which may be a service concern, but nothing will happen. So this is the implementation of task queue. As I said, there is no hard real-time requirements you implement task queues. Of course, you need to see whether SMS are being sent or not, but I don't think it will be a huge problem if you get delayed SMS. We do get delayed SMS sometimes. Okay. So if Celery is broken, that's fine. Restart it; it will work, no problem.
Where is RabbitMQ physically storing this information? Is it in memory or is it on disk?
It's in memory right now. The RabbitMQ queues are in-memory queues.
So if that crashed, you lose everything.
If RabbitMQ crashed, you will lose everything, but you can even run RabbitMQ in a cluster mode. So they just do copy, but it's pretty stable for Celery related things. RabbitMQ is used in very complex scenarios. I've never seen it crashing, but yeah, it can. If it does, yes, you will lose it, which means your client has to look into the logs and trigger the task again. Okay. There is a way to avoid that. We are going to look into that in a moment. Okay. So you understand why we have RabbitMQs. What is the clients? What is the server Celery tasks? Is it clear, guys? Because it needs to be clear. Any queries you still have? No? Okay. So I was talking about these workers. Let's come back to concurrency and workers. By default, it creates number of workers which are equivalent to number of what? Cores in the system, correct, right? But you can control this, right? We do not want all cores to be occupied all the time. You can control this. You can control it via a command line parameter called --concurrency is equal to give the number. Okay, sorry, I just pressed enter. So if I say 1, you can see there is only one worker is forked. Okay. If I do it 3, 3 workers will be forked. What will happen if I give the number which is more than the number of cores in my system? So all of you know that I have 10 cores in my system. What if I give 20? Should be okay? Okay. Generally it should be okay. Okay, like you get 20 workers. But this is where you need to understand your problem again, whether you need it. And you have to understand one thing, or actually remember this: number of workers you can fork is decided by U limit. If your U limit is crossed, number of workers will give you an error. And believe me, you don't want to get that error, because Celery doesn't check the available descriptors and then decide not to do it. Let's say you have 10 descriptors available, you say 20, it will start 10, but it will crash after after 10, which means all your 10 Celery instance worker which is running will be in a kind of limbo state. You need to physically go and kill it. So you need to be very careful of how many file descriptors you have available. U limit is the number of file descriptors that can be open at any point of time. So all workers are forked using a file descriptor. Okay. It has different limit, you can set it to any number you want, but again the performance constraints will be there. Okay. So let's look into some of the examples. So what I did in this example is that I added sending WhatsApp also along with sending SMS. Okay. So you can see I have created 2 tasks, one task for sending SMS, another task for sending WhatsApp message for the same withdraw or deposit amount, and I am calling delay for both WhatsApp and SMS. The code is clear, right? I am going to execute it and we will see it later. The code is clear, right? So I have 2 tasks, sending SMS and sending WhatsApp. I don't want to do it from my banking system. I am putting these into RabbitMQ, and Celery is going to pick it up and execute it. Okay. So this is my code. Okay. Now you have to answer me a few questions. Okay. Starting my Celery, and I am calling this send SMS, send WhatsApp delay. Can you tell me whether these 2 will be executed simultaneously at the Celery or one after another? Because I have put a sleep of 5 seconds in both SMS and WhatsApp. You can see line number 11 and 16, there is a sleep of 5 seconds. This is the first code of the chapter concurrency. What will happen? Any guesses before I show it? So when we create Celery, it creates multiple workers. So in my case 10 workers are there. So I am just asking 2 functions to be executed. 2 workers will be free. It will execute. So if you see, sending SMS timestamp is same as sending WhatsApp timestamp, because 2 workers are used. Okay. Now what will happen if I say concurrency is equal to 1? Okay. So same thing, I am running with concurrency is equal to 1. What will happen? Yes. So you can see that at 12, there this SMS is sent, at 17th second WhatsApp is sent, because there is only one worker. So by default you have multiple workers. If there is only one worker, you are gonna have to wait one by one. It will be sequential. Okay. Clear till here? So I'm going to share all these documents with all of you. No need to take notes of it. Just make sure you understand it over here.
When I ran that, I got an error from Celery. Received unregistered cache, but that's a
Sorry?
Yeah, switch in the number folder and then run the test again.
Okay.
Yeah, and that's started.
You can try running it once again. It should work. Or do one thing. If you are getting some error, take a screenshot. In the break, I'll come and see. So if your number of file descriptors will be, exhausted, you will get this OS error, too many files open. And believe me, if you are getting this error, you need to restart your complete Celery part. You don't want to continue working in there. Now there is another important thing, which is auto scaling and descaling. So we do not want 10 workers all the time. At the same time, I also don't want single worker all the time. So there is a parameter called auto scale, which helps us to auto scale based on the load. Okay. So we can provide min and max. So let me go to the second folder of this. And I am using auto scale. 1 is minimum, 10 is maximum. You can use this parameter auto scale. So you can see in HTOP, by default, only one worker is created, the minimum number you stated. And if we increase the load, the number of workers will be added automatically. You don't have to do anything. And pretty much in all the production level Celery code, you are going to do this. So in here, if you can see this particular code, what I'm trying to do is that I'm sending SMS and WhatsApp in a loop. Okay. So I'm sending, let's say 10 WhatsApp and SMS in a loop. And if I go ahead and run this, you can see in HTOP that number of workers increased automatically. We started with one worker. Since there were 10 simultaneous requests, increased automatically. So this is auto scaling. How to do auto descaling? So it will take some time to descale, because when Celery says that I have 10 workers, it will be expecting more and more data to be coming. But if your queue becomes empty next time, let's say I'm just sending only one request, 2-3 times, then the number of workers should reduce automatically, because it doesn't need that many workers. No, there is no time limit. So the question is, there any time limit to descale? There is no time limit. What happens is that it scales and descales based on number of requests that are there in RabbitMQ. Okay. So at any point of time, if there are more than 10-20 requests, it will create that many workers. But if the number of new requests are reduced, it will reduce automatically. So it's not a timer. It's the way it pings the RabbitMQ, that's the internal implementation. Okay. So right now it came back to only one worker, which is descaling. So any production level Celery system, you are going to use auto scaling. You don't want to use all the workers all the time. Yes, sir.
Could you show the command again with the auto scale?
Sure. This is the command.
workers, and then it only spins up workers when it needs a worker or when a task hits a queue?
That's a very good question. That's not a naive question. That's a very good question. And I just realized I haven't tried it yet. Let's see it. So the question is, can we get minimum at 0? So I haven't tried it. Let me see what happens. Okay. Yep, looks like it's working. No workers. Okay, so next try is negative numbers. I don't know. Okay. Ideally, should give some error. I don't know. -1. Consider it as 0. But that's a very good question. I learned something today. Okay. And what will happen if I run it? It should actually start. Yep. Okay, so we learned two very important things. First is what is Celery, because it's not like a library where there is only one system out there. You are calling the functions and API and get your things work. It's more about creating a system, okay, where the tasks can be coming from different producers, can be used by Celery consumers. Okay, and I told you there are two situations you want to use it. What is the first one? There is no hard real-time requirements. You are getting WhatsApp after 2 minutes, fine. Okay, all our social media updates like Instagram, Facebook, we don't get it in real time. Some people will get it in 1 second, some people will get it in 5 seconds, and so on. So there is no hard real-time requirements. Right? Same for LinkedIn updates. Apache Kafka came from there, so I am quoting that example. There is no problem if you get some notification after some time. It's no hard real time. And second, when you want to make use of multiple CPUs that are available around. These are the two cases you want to make use of Celery or something similar. Okay, so concurrency is enabled. GIL is not a problem for Celery. By default, it will take care of it. You don't have to create multiple processes, multiple workers. You got it covered. Let's go to chapter 3. Okay, in the folder structure, you can go to chapter 3. So what is a delay, which we add in all the task functions? What is the meaning of delay? What delay does? Puts the task into the task queue. Right? Make sense? So delay is not the only way to put task in the task queues. There are other ways also. Okay? And the other way is called apply async. You can see it over here. So I can call either delay.delay or apply async. With apply async, I can provide more parameters. Okay? For example, this countdown parameter. Now, in the previous example, if you remember, in both the function of sending SMS and WhatsApp, we say time.sleep for 5. We slept for 5 seconds. Right? We slept for 5 seconds. But that sleep will block your worker. Yes or no? Because once the worker starts executing and you are sleeping, that worker is blocked. I don't want that. I want that some delay, if it has to be some delay, it should come from the client side. Client can tell you, okay, after how much time you want to execute this particular task. In that case, our workers will not take that task till that time, which means the workers will be free. And that's what you can do by providing a single parameter called countdown. Okay. So you understood why we want to provide this delay parameter or sleeping parameter from the client, because we do not want our workers to be blocked, right. So let's go to our chapter 3 files. So in this implementation, I have removed the sleep. Okay, I have removed the sleep, and I am calling this with apply async by passing a parameter called countdown equal to 5. What should happen once I run this? In here, you can see after 5 seconds, both of SMS and WhatsApp should get executed. So I am not sleeping. The benefit is that I can even change it at runtime. I am not making it static. So something will be 5 seconds, something will be 10 seconds. I want to do it because some other reasons. So you can see SMS is at 59 second, and 4th second is WhatsApp, right. Okay. Now a question for all of you. What will happen if I say concurrency is equal to 1? Both has 5. What will happen? Any guesses? Should run synchronously. Okay, that's one answer.
It waits 5 seconds and both run as fast as they can on the one working. So they both wait 5 seconds when it's received, and then whatever the processing time for sending is going to.
Okay, let's see. Your answer is correct. At 59th second itself, we are running sending SMS. 59th second itself, we are sending WhatsApp. So with the countdown parameter, it's not synchronous because workers are not blocked with it. But if you put a sleep at the task, workers will be blocked. It is not taking the task till the time is there. Right. It's still in the queue until the time is up. Absolutely. So it's not good to put sleep in your Celery task. There are other ways to do it. Okay. I mean, why you want to have some countdown? Because maybe you want to, while sending WhatsApp, you want to say that SMS is already sent to you successfully. You want to confirm to your customers. Okay. So if you want to make use of these kind of parameters, you need to use apply async. These parameters are not available with delay. Delay internally use apply async. Okay. So delay is the simplest. By far, it's the simplest way of making sure everything is working. But if you want to play with some permutation and combination, and some of the permutation combination we are going to see in the next chapter, you should use apply async. So apply async is clear. Give me a thumbs up. Okay, thank you. There are few other parameters, but I am not covering those things in this right now, okay, because they are not that important in my context, maybe, but we can talk about it, here in the conference. After that, we'll talk. So when you want to send parameters, all of you know arguments and keyword arguments, right? Python arguments and keyword arguments. Args and quarks. Okay. You can send args and quarks with both delay and apply async. Okay. Now in this example over here, I am sending args and quarks with delay as well as with apply async, but the outcome will be different. And I want all of you to see the screen and let me know what's the difference. Okay. So let me go to the second example. So I am calling delay as well as apply async to pass arguments and keyword arguments, but the outcome will be different. You have to see the outcome and tell me what is that. Okay, let me do it once again. What's the difference in the outcome of output of both delay and apply async? Yes.
But it's like how the type that's being received looks like.
The difference is you can see keyword arguments. Yes, anyone else want to point out the difference? Yes.
The delay, or rather the apply async is sending the arguments marks separately, and in the delay, it's just all marks. There's no keywords applied, so it looks like one tuple.
Sure, absolutely right. So in the apply async, you get args and quarks. Look here, these are args, these are quarks. But in delay, you get everything as an argument. This is a tuple, this is a dict. It doesn't differentiate args and quarks. It treats everything as arg. You can see here, right? Apply async. So if you want to send keyword arguments, you have to use apply async. You don't want to send, use delay. This is a very important difference. You know, people, I have seen people struggle to find the root cause of the problem because they are sending args and quarks. Okay. It's not that clear in the documentation also. That's why I covered it here. Okay. You saw the difference? Is it working for you? Some of you trying it? Just try this particular example because there is an exercise after this. So try this particular, chapter 3, folder 2. Go to your chapter 3, folder 2, start the Celery. Make sure a RabbitMQ is already started. Start the Celery and run this entry point. Should be able to see the same output. Show me a thumbs up once you are done. Good. 2, 3.
Why would you ever use delay?
Simplicity. Simple. It's it's just simple to use delay. If you are calling some task just for logging purpose, for example, you will never use apply async because the primary reason for using apply async is to pass additional parameters. You can do that, but as a rule, if you say if I'm not passing any additional parameter, I use delay, then it could be a kind of coding convention for you. But apart from that, functionality wise, you can use apply async, no restrictions. So we used delay for logging. Just we need to log what happened. No, I'll share it after this tutorial. I'll share everything. I just shared the code. So you understood till now? Yes, no, maybe? Take it as a yes. Okay, there is an exercise in this document, but we'll see if we want to do it at some later point of time. The exercise here.
So one thing that's also different, and I'm not sure I understand why, is that the first argument in the is a tuple 1, 2, 3, 4, 5, and then below it turned into a list. No, farther down. The 1, 2, 3, 4, 5 is now in square brackets within the tuple.
So this is a delay output. So
Yeah, right. So the delay output turned it into a list, and in the async, it kept it as a tuple. That seems pretty significant.
yes, so basically in delay, it just take parameters as raw parameters. In apply async, if the parameters are raw parameters or argument or keyword arguments, it will take care of it. It will give you like that. Otherwise, it will just give you as a list.
Just on the second note on that one, I understand the first reason of the first one, but on the second one, where can I apply that? Like, what's in this scenario in your company? What's the reason for using the cycle or having that whole
When you are logging, okay, when you are logging, that's a plain and simple way of sending things. Okay, so logging is not every time you write something, things are written on the disk. There is a journaling system, right? Similarly, if your code is getting executed, you want to combine a few things and then send it at once. So delay is just simple to use. You don't want to have different categorization there. It's the log, just write it as it is. So in these cases, you can use delay with this. Okay, remember this picture. We are moving to chapter 4, which is two-way communication. Remember this picture which I shared in the beginning, that you send the items in the task queue and you forget about it. The task will be executed. You send the SMS, SMS will be sent, whether it is sent in a few seconds or sent after 2 minutes. Doesn't matter, right? But there will be genuine reasons for which you should know whether SMS is actually sent or not. Maybe for service auditing purpose, legal reasons, you need to make sure that you understand, or you keep a log of whether things are actually happening or not. For that, we need two-way communication. Two-way communication is not synchronous communication. Two-way communication doesn't mean synchronous communication all the time. Until unless you are waiting there, it remains asynchronous. Okay? So to use the backend, to take the return value, you need to use a backend in the Celery. So Celery uses something called RPC for the backend. So basically, it makes use of the same RabbitMQ queue to send you back the responses. Okay. So the only difference between what we were doing till now and now is that we are providing broker, yes, and we are providing backend also. If you do not provide anything as backend, Celery will not be able to return you back anything. But if you are providing backend, you can get the results. Okay. So you understood the purpose of it. You may need to know whether the logs are written or not. You may need to know whether things are processed or not. Maybe you can log it somewhere that, okay, these many analytical things are being processed. So here is what the changes we did in this particular chapter. Same file, same code. Only thing I have added is return statement. In both send SMS and send WhatsApp, I am adding return statement. Okay. And to get the results, I am using .get on those tasks. So till now we were doing SMS send, WhatsApp send .delay or apply async. Now after doing that, I am saying .get to get back the results. Will we get back the results? Yes, we will. Okay, why don't you do one thing? Can you run this particular example and see whether you are getting back the results or not? Chapter 4, folder 1. The code is already there. Difference is in the client code I am calling get, and I am returning plain and simple text messages saying that WhatsApp is sent, SMS is sent. See what happens. Working? So this output you have to see in your client. It will not be visible in the Celery window because output you are getting and printing it in your client, just like here. So while you are doing this, in reality this is a synchronous system right now. Okay, I am sending and waiting it before this function completes. So this becomes synchronous, but in reality what happens, you will not wait here, you will send and forget, and in other place you are going to wait. So you will use this handle SMS status, WhatsApp status to get at some later point of time, or it can be a totally different system altogether. So you understood why we need return value? Anyone can tell me any other scenario for which we need return value? Sorry? Yeah, confirmation you did it all. And
Send a response back to the user. You know, if it was like not necessarily just sending him a notification, you know, say it's a web service, you could send a JSON response if you're processing like database transactions, something like that.
assume I have purchased a premium service like DMs or WhatsApp. Okay, and if I have purchased that, and if I am not getting the message, I'll be troubling you, right? So we need, most of the time we need some confirmation that things are being done. If we do not want to send it to our customers, at least in the logs, we need to make sure that things are done. Okay. So is it working for all of you, for the people whom it was working? Good. Okay, so before the break, let me take the most significant chapter of Celery. Okay, this is where the advanced topic comes into picture. This is the most important chapter because this is how you are going to make use of Celery in your production system. And the chapter 5 is signature and chaining. Okay, so just look at this picture over here. Don't need to see the code for this. you all know we can just call apply async or delay, right? So signature is you create a template. Okay, in the modern languages terms, your template invocation is a signature. So what I did over here is that I've created a signature. You can create signature by using .si or .s. I am passing the parameters, so sig SMS become a templated entity, just like a template in C++ or Java or C#. Okay, and you can call this signature SMS with delay or apply async, or apply async with some parameters. Can you see any usability of this? If I create a signature, can you see some use cases where you want to use signatures? Secure communications? Okay. Yeah, in the sense your parameters will not be changed. Yep. Any other things? The signature, it's modified, but it is a modified signature. So you use signature so that you don't have to, primarily you don't have to change the parameters. For example, you are sending some customers, they are premium customers, and you are having different greeting messages for them. Okay. You create a signature. That will be same for most of your premium customers. Apart from name, you pass the name, that's all. Rest of the messages are same. Your other category customers, you can give another message, something like that. Okay. Another example is that you are creating a database of your local community, maybe the zip code is same. Create signature with zip code so that you don't have to put the zip code in all the function invocations, so that you are not getting any mistakes over there. So signature is just, consider signature as a template. You create a template of invocation. You create a template of invocation and you can invoke any number of time. The parameters will be same because it's a templated invocation which is already done. Yes?
Is this sort of the moral equivalent of a partial function? So that, because maybe you can't use that in the Celery world because of the...
You are absolutely right. So signatures also used for creating partial functions. Okay. So in that case, you don't use si, you use only s. Si becomes immutable, so it cannot be used in the partial functions. So only signature you use s. Then it can be used in the partial function. Yes, that's one example. That's correct. Okay. So
You said you could pass in it, like the name would be different for the template, but that's another parameter. So are there some parameters that are part of the signature and then additional parts that are added that are unique?
So in this case, apply async, you can see the countdown parameter is added on that signature. So the function parameters, if you state it once, you cannot change, but other parameters of the delay or apply async you can change.
I can't change account number or message, but I can change things about the async, the indication of it.
Yes.
I can't change the name in your previous example.
Yes, you cannot change the name. Yes. Can you use signature as a parameter in a signature? We are going to see that in a moment. Okay, so all of you know now signatures. Signatures are templated things. Okay. One of the example of signatures is that you can create a group. Okay. For example, I know if a transaction has happened, I have to send SMS as well as WhatsApp. Okay. But I don't need to first call SMS, then call WhatsApp. I know these two things has to be done. I can create a group of that task. Okay. And on that group, I may be calling delay or apply async. Look at this code, self-explanatory. So I have created a signature for SMS and WhatsApp, and I have created a group which consists of two signatures, SMS and WhatsApp, and I can call the group. Both of the functions will get called.
Do they take up two threads or the same thread inside the Celery? Like when that group is called, am I invoking two workers or a single worker?
So generally it happens that the worker which does the first task of the group, generally it will pick it up. But if that worker is busy, another worker will pick it up. So overall behavior, it doesn't changes. Okay. So whenever you see this messages, you can see this pool worker numbers. Okay. So looking at these numbers, you can understand whether it is being picked by the same worker or different worker. The way Celery is implemented is that there is no hard rule. Okay. Group is mainly for each of calling functions at the client side. Doesn't changes the behavior from the server side. From server side, it's a two function, two tasks will be executed. Just that from the client side, you have less number of lines for that matter. So can all of you go to chapter this chapter 5 folder 2 and see if this group is working for you? So regarding your question, you can see that when I triggered a group, SMS came to worker 8 and WhatsApp went to some other worker. Okay. So the behavior at the server side will not change. If the workers are busy, same worker will be used. If not, another worker will be used. Any questions here? I know it's getting a bit boring, but yes. No. From the Celery task perspective, there is no difference. It's just a better way of for your clients. You can group 10, 20, and then it will make sense.
Does the order in which you group them matter?
The order in which it will be put into the queue in the order you have put it into the group. Okay. So if SMS is there in the group, you can change that. In your code, you just change WhatsApp to the left side, SMS to the right side. See what happens. That's one classroom exercise. In this group, change the order. Say WhatsApp first, then SMS. See what is getting called first.
What happens if one of the tasks errors? If you've got two tasks in a group and one of them errors, Celery just hunts that thread, right, or that worker. The group is not affected.
No, group is not affected. What will happen that let's say send SMS is crashed for some example, or it is throwing some exception. The WhatsApp is not picked up by a group, by a worker as yet. Okay. So once it is completed, even after exception, the WhatsApp will be taken over by another group.
Typically with send async, you have an error retry parameter.
Yes.
Go over that.
Yes.
What happens to the group? Like, does it send both tasks back again, or is the item?
No.
does it know
No.
one?
No, it is similar to you are calling with retry parameter different times. When it happens in group is just an abstraction at the client level. When group executes, send SMS is a separate entity in the task queue, send WhatsApp is a separate entity in the task queue with the retry parameters. Yes. Okay. Similarly, you can get the results of the group by calling the result.get on the group. So we were getting result by calling SMS send.get, WhatsApp send.get. Now in the group, when you say result.get, you will get the result in a list form. Okay, after this, I hope it will be interesting. So group results we were talking before we took the break. So when we get the group results, we get group results in a list. Right now the group results are WhatsApp and SMS. What will happen if I change this sequence? What will happen? It will swap. SMS will be sent, result will come first, then the WhatsApp. Okay. Now before I go to the next topic, let me show you something. Have you seen these kind of data structure? So basically what happens over here is that you do some work, take the output to the next node, okay, it's just like graph, take the output to the next one and something like that. Many a times when you are using any server side system, including Celery, or for processing large amount of data, you need to create some kind of chains, okay, where one thing gets executed, the result of that gets updated to the next one and next thing gets executed. So this is the thing you can do in Celery by chaining of the tasks. Okay. So just look at this particular function and maybe please guess what we are doing over here. I have two signatures, SMS and WhatsApp. Earlier, we created a group, okay, and we called the group using group.delay. Now I am creating a chain, sig SMS, sig WhatsApp. So chain is similar to this data structure, which I'm showing in the screen right now. So basically what is happening with chain is that sig SMS will be executed, the result of sig SMS will be given to sig WhatsApp. So the use case over here is that while sending the WhatsApp, I want to tell my customer that SMS is already sent and you must have received it by now. Okay. And let me show you the code of task 1. Now look at this task. Send SMS returns true and send WhatsApp takes 3 parameter instead of 2. First parameter is SMS send status, then account number and then message. But from entry point, I am sending just 2 parameters, not 3, as we were doing earlier, right? Difference is that we are creating a chain, which means the output of first execution should go into the second one. Okay. So what will happen if I go ahead and run this? you can see send SMS status is true. So at the server side, at the Celery side, the output of first task chained into input of second task as a first parameter. Doesn't have to, but this is if you are actually doing chaining, because if you are actually calling multiple functions, you will have to.
Does that support any type or just native types?
Any type it will support. Python is anyway dynamic. So when you want in group, both tasks are executed simultaneously. In this case, you are making sure that first task is executed, then second is executed. That's what chaining is all about. Just like name, chain. They are linked together one by one. Okay. And okay, there is one example of chords, but this doesn't works with RabbitMQ, but works with Redis. So I'm going to talk about Redis later on, and that point of time I'm going to show you this particular, example. So we are going to go into something interesting called state management. But before we talk about state management in Celery, let's talk about what is the meaning of state. So all of you heard about something called state machines. What is a state machine? If you want to define a state machine, is that anything that remains in memory after executing is a state machine. So if you are writing a very simple function saying that input 2 number, I will give you a sum of it, and after that function terminates, it's not a state machine. But if that is running on a loop and keep on asking input 2 numbers, I'll give you the sum of it, that's a state machine. The state will be calculating or waiting for input. All softwares we write is actually a state machine in one way or other. Okay? And Celery is not an exception to this. You will have to manage states in Celery, or for that matter any system you create your software with. So state is defined by conditions and behavior. Which state I am in? Let's see an example. I am in a happy state, right? Conditions and behavior define my states. Conditions, what all things I can do in this state. Behavior, what will my outcome will be in this particular behavior, this particular state. Another state is sad state, right? This is a generic example, but in a program you have multiple states. You have an init state, you have execution state, you have user input state, you have multiple states. And if you create a state machine, you will be in a better position to understand what is actually happening in your system. Let me give you a simple example. Assume you have a code of, let's say 10,000 lines of code, and it crashes in between. What you need to see? Where it crashes, how it went there, and so on and so forth. But in those 10,000 lines, each 1,000 lines represent a state. And if your code crashes, you know which state it was, then the area you will look for that particular problem will be less. So your code, your program should be a state machine. If it is a state machine implicitly, but if you create a state and manage it in the form of a state, you will be in a better position to write higher quality code. Okay? So the basics of a state machine, I'll just cover it in 1 or 2 minutes. Like state machines have events which triggers transitions. Okay? For example, I'm in a happy state, I lost money, I transition to sad state. But when I gain money, I transition to happy state. Generic example, it's not meant to be, Okay. So lost money, gain money is events. Events triggering a transition. For example, user giving me input 2 numbers. Okay, when 2 numbers are given to me, that is an event which is triggering my transition from user input state to execution state. Okay, so this is the way you create a state machine. Now, how to do this same thing in the Celery? So I talked about state machine because you need to understand why you need state machines. Okay, so when you go back and look into your software, after this session, look at it from the perspective of state machines. You will realize that you have actually created a state machine even though you haven't created it implicitly. Okay. So in Celery, there is a concept called bounded task. Okay. Bounded task means, in terms of Python, we can say that we have the access to self. If we create a function inside a class, we have a self, right, with a self parameter. A bounded task has access to self, which means by default there are lots of parameters we can make use of, like request ID, name, arguments, keyword arguments, and so many things. Right? Let's see example. So in chapter 6, the first example, I've created a bounded task, okay, and I'm printing some self parameters. Okay. So you can also just go ahead and run it once so that you can get an idea. So I've just called the bounded task, and you can see task ID is there, name is there, whatever the arguments, keyword arguments I have given is there, task status is there pending. So this task status will change to complete once the task is complete. Okay. So most people do use this task ID. This is unique for a task, so they use this task ID. But all these parameters are not sufficient to maintain a full-fledged state machines in Celery. And I know that if you are using Celery in your production system, you will end up creating states in one way or other. So I'll tell you a way to handle states in Celery. Okay. So this alternative method is not given by Celery. Since we have worked on this, we came up with this. So I thought I'll share this with you, will be useful. So basically, I have created a state class on my own. Okay, this code is there in the examples. Okay, and very simple state class with some number of states, action taken, result taken. Since Celery, we are passing task from Celery from the client to the Celery, we need to do serialization and deserialization of states if we want to manage states at the client end also, server end also. Okay. So small code of JSON serialization and deserialization, and you can use these things to manage your state in Celery. It's very simple. Okay. So if you are writing any production level code, the first thing you should do in your Celery is create a state machine. Identify what all states will be there for the task to happen. Right? You may be sending that task to somewhere for MapReduce. You may be sending that task to some other third-party software, or you may be keeping a count of how many tasks you have executed. You can do all those things and incrementally add a new things if you are using state machines. Okay. So it's my serious recommendation that whenever you are trying Celery, the first thing you should create a state machine, because you have to understand what you are trying to do with this. Okay. Even if it is as simple as counting the number of times task gets executed. Okay, so you can create a state machine. So basically, in this particular state machine, what I'm trying to do is that I'm trying to keep the task that is called and the results that are there. Okay, and now what I will recommend you to just go ahead and open the code in the folder 2. Just have a look. Let me know if you understood the code. Just have a look at this code, and this is not core part of Celery, so I don't want to spend more time on this, but I do want all of you to understand the concept of state machines and how you can create basic set of states. So this is a crude example, but at the client end, what I'm trying to do is that I'm maintaining a state with client ID that at this moment of time, only one action was taken and the result was success. And at this moment of time, 2 actions were taken and the results of these actions are there. Okay. So basically whenever, so you don't want any client to call some actions which is not intended for that client. You may not have control on who is writing your Python client, Celery clients, right? State machines comes in handy over there. You can directly reject the things based on the available client list that can call those functions. Maybe one client can call multiple tasks, another client can call less number of tasks. You have to believe me on this, because if you are writing Celery, create a state machine first. Okay? It will make life easy for all of you in your production code. Okay. And if you do not want to maintain the state at the client end, you don't need serialization, deserialization. You can directly maintain the same state at the server side, Celery task side, and you can log it. And then if some problem happens, you know which state it happens, because Celery multiple workers will be running. Debugging is not so easy. Where it happens, what action triggered this particular error, okay? Then you need to understand which state it happened. State will drastically reduce your area of focus. So go ahead and after this tutorial, go ahead, you take this particular code with state machines, use it, change it, do some permutation combination. If you are comfortable with state machines, you are comfortable with writing not only Celery but also any other task queues you are going to use. Yes.
So like this is like the next logical progression from really like chapter 4, right? Like we're doing two-way communication, but with purpose, I guess.
Yes.
Okay.
Yes. Absolutely. Because as I told you, that when I'm going to cover advanced topic, it will be good enough for you to say that production level code in Celery. To have a production level code in Celery, state machine is a must, and by default bounded task will not give you enough information for managing your states. You have to do it separately. Okay. So make use of this state machines. I hope all of you understood the idea behind state machines. Yes? Okay, show me a thumbs up. Yes. we are going to look, very good question, we are going to look into queues now, okay, and see if it solves the problem which you are trying to say. Okay, if not, we'll discuss that. Okay, so state machine happened. Let's go to chapter 7, which is managing queues. Okay, so by default, when you see your RabbitMQ and you see queues, okay, let me restart the RabbitMQ because lots of queues are there. Okay, so so by default, when I create queue, I mean use Celery, a default queue is created in RabbitMQ in the name of Celery. Okay, there are some management queues, don't need to worry about it. Okay, so Celery queues are D is nothing but DQ, okay, doubly ended queue. So these Celery queues are created by default in the name of Celery. Now there are situations where I want different queues for different types of work. For example, I want different queue for sending SMS, different queue for sending WhatsApp. For example, if SMS sending is taking more time, which it will be because based on the SMS gateway will be slower than your internet gateway for WhatsApp. So your WhatsApp is not delayed. How can I achieve this? I can create different queues. Okay. So in Celery, it's possible to create multiple queues, and here is how we can do it. Very simple. In your Celery, provide a -q parameter and all the queues you want to create, comma separated. It could be only one. Celery is by default. It could be only one, or it could be comma separated multiple queues. Okay. So let me go ahead and run this. I think I am running the 7th one. And we can actually check the number of queues that are there by this task, calling inspect active queues. So by default queue right now is Celery, you can see. So whenever in that particular task you go and say inspect active queues, you will see the default queues and lots of status related to that queue. Okay. And as I said, with -q parameter, I can create queues. Let's say I'm creating first queue, and let me inspect. Can you try this example, the first one? So if I created a queue named first, when I inspect the queues, you can see first queue is there. Okay. Are you seeing this in your screens? Are you able to see this? Most of you? If not, you can look into your neighbor's screen and see if it is working for you. I can also create comma separated queues, first, second, third. And when I inspect, I can see first queue, I can see second queue, I can see third queue. Okay. And if you go to RabbitMQ, you can see first, second, third over here. So you can create multiple queues in Celery. Okay. And
Celery is still there, I think the default queue is still there.
default queue is not there.
That's the same.
It's there in the RabbitMQ because it's not auto delete, right? But when in the context of that Celery application, on that if you see the inspect queues, the default queue is no longer there.
What does it mean if I just have a bunch of queues that are all UUIDs?
Sorry.
On the queues and streams panel on RabbitMQ, there's quite a few queues that are just UUIDs. Are those from like earlier?
Yes.
Okay.
So I also restarted RabbitMQ just to make it bit clean.
Okay.
Okay. So this Celery queue, because it is not auto delete, it's a RabbitMQ parameter. Even if it is there, it's not a problem because the queue, nothing will be there. But if you want, you can delete it. But in the context of this Celery, where I am saying only 3 queues, first, when I define queue, by default queue goes out of picture. Okay, there is no by default queue. Okay, so how to send task in a particular queue? From yes.
I just wanted to make sure I have that command right, it's just dash queue as in the name of the task.
Yes, no, it's just the task queue, name of the task queue.
Name of the task.
Yes,
I'm getting no option dash queue.
you are
Yeah.
minus q will be there. Anyone else is facing the same issue? Show me a thumbs up if most of you can create queues. We'll have to check, sir, in your laptop. Do that. We'll have to check your laptop. I'll come there after this session and do that. But maybe you can look into your neighbor's screen. And okay, so from the client side, now there is no default queue. Okay, now there is no default queue. By default queue was Celery. So from the client side, you will have to specify the queue name, which queue this particular task will be executed. Okay, this example over here, I'm sending SMS to queue number first, and I'm sending WhatsApp to queue number second. Okay, so in this example, you can see. So if I go ahead and run this, what will happen? It will run, right? Okay, and here you can see sending SMS, WhatsApp is there. Now let's assume that I'm calling 2 functions here. Put task in the first queue, put task in the second queue. What if I don't specify any queue name over here? What should happen? What should be the behavior? Okay, so when we define the queue, there is no default queue. Correct. So right now you can see this is blocked because this is synchronous call, right? Put task in first queue. I am putting task in first queue and I am waiting for the result. Since there is no default queue, it is stuck in RabbitMQ in the first queue. Because there is no default queue, it doesn't know which queue it should go into. Okay? So there are two ways out of it. Kill this program or start start Celery with a default queue. So that the tasks which are not designated a default a specific queue will go to default queue automatically.
Could you get around that by defining a queue named Celery?
No, there is no queue named Celery once you define it. If you are okay, let's see it once again. Am I misspelling anything? Oh, instead of worker should not be there. So you can see when I have created a queue with the name first, second, third, there is no default queue name Celery. We have overwritten the behavior. If we are defining the queue, Celery is not going to create a default queue for us. If we are not defining a queue, Celery will create a default queue for us. Okay? So there is no default queue name Celery. So we cannot go around it. We'll have to create instantiate Celery again with a default queue. Okay? So in here you can see it's still, in the limbo state, it's still waiting. Okay? So we have to define the queue over here. But we can define default queue by specifying a parameter called first and task default queue as first. Any queue name we can define as default. Okay. So this is the second folder. So let me run the same example again, this first entry point, which was stuck there because there was no default queue. Okay. Now it will stuck there forever. But if I go ahead and run the Celery again with default queue, okay, I'm not sure why it's not responding. Can you try this one? Create a first, second, third. It should work. So what I think I did is that I make first as default queue.
We've got here in the one folder, right? So that changes in two folders. So if you run entry point in two folder, I think you should do it, right?
Let me do that.
For the client or the application.
Okay, there might be some mistake I did because it should also work there. But in case of 2, you can see there is no queue specified over here. Okay, if you go to folder number 2, you can see in the task 1, I have specified first as the default queue. And in the entry point, I am not giving any queue name in this particular first one. Okay. Then I am giving first and second queue name. So basically it means that from the client side we can decide which queue a particular task will go in, and there are n number of benefits for creating multiple set of queues. Again, in production system it will never happen that you will end up creating only one queue. So there was a question earlier, like in case RabbitMQ crashes, it's most likely the queues are getting into problem. So if you have multiple queues, the chances of one queue getting into problem and killing everything else will be reduced if you have multiple queues. Okay. Now this was from deciding the queue from the client side. You can also decide the queue from the server side. By specifying the name of the queue in the app.task decorator. Okay. So what will happen over here? You are not specifying the queue while calling the task, but that task will go to the queue specified by this particular decorator. So again, this is from server side. Previous example was from client side. Let's run this example quickly. I'll recommend you to go ahead and see example 3. Just run it once and see if it works for you.
Are you typically having multiple workers service different queues?
Sorry.
Are you typically having multiple workers service different queues in the work scale out?
Yes. So you should get this first, second, third task done from your client where we are not specifying any queue. Okay. In the task 1, we are specifying the queue. So this is all you can play with to come up with your appropriate strategy, how many queues you want to create, and also when you are creating state machines, you can also keep the task queues on which the task is executed. Okay. So again, I'll just reiterate, state machine is a must for any production system. This example working for you? Yes.
If you don't have a large number of states, would it be reasonable to have a queue for each state so that by virtue of the message being in a particular queue, it's in that state?
That can be a design decision, yes. So show me a thumbs up. Yeah.
Well, I was
client will not be able to do that. So queue, when we pass the queue parameters from the Celery task, so it's server end. So clients cannot create queues. Okay, they can connect directly to RabbitMQ, create queues, but that is of no use for Celery, because Celery should know that this queue is meant for Celery task. Okay, so most of the things which we are going to use in our production system, we have covered in Celery. The things which are not covered is some of the specific parameters that we are going to make use of, but those were simple enough to understand from the documentation. That's why I haven't covered it. But there are something I want to cover is the management of, monitoring and management of Celery task. So one of the things which is used for monitoring, there is one thing pending about Redis which we are going to see. So by default, you can use Flower to monitor your Celery tasks. Okay. So once you install this particular package Flower, you can start it by using this particular command. So this is your RabbitMQ details. If it's the IP address, it's the IP address, the username, password, and you can use this to create the instance of. So you can see by default it opens up in port number 555, sorry, 45. Okay, so this is how you can see your Celery in action. Let me run it. So I'm calling this function, let me call it two, 3 times, and then see. You can see which task was called and what was the results, which worker did it, and how much time it took. This is very important because either you add logs to understand few of the steps mentioned here, or you can use this tool to just see how your Celery is working. Okay. So by default, this Flower is recommended by Celery, but in a production system, you generally use a time series database, okay, and tools like Grafana. Okay. So let me show you how you can use a time series database like Prometheus. Okay. So this is optional for you, but I just want to show that you directly link this Flower to Prometheus and get your time series results, because this will give you data. Flower will give you data, but it will not be having the characteristics of a time series, right? So you need to use time series DB. You can either use InfluxDB or Prometheus is widely used, good enough for Flower. It's not having so much nanosecond kind of things. I mean, if you have to have too much precision, then you can use InfluxDB. Otherwise, you can make use of Prometheus. Okay. So this I will share with you. It has all the steps to set up the Prometheus for you. So how to change the config file, how to set up the targets. Okay. I've set it up. Let me see if I can just run it quickly. Okay, so by default it goes to localhost. So you have your Prometheus. In the Prometheus, if you say Flower, all the events that are there for Flower, you can have that in your Prometheus. So if you just say FLO, you can see all the things in your time series DB. And once you have things in your time series DB, it's great. to have logging or understand things, their historical data, whatever you want to plot. Okay. It is taking data from Flower itself, but it's giving you the time series properties which you can use directly in Grafana and other places. Okay. Let me see if we can make use of Grafana also, just to show you. By default, login is admin. Don't tend to change it. So in the Grafana, you can have your data source as Prometheus. Okay, since I am using a Docker container, my host ID will be a bit different. You can save and test, working fine. You can go in your dashboard. You can create a dashboard. You can take a visualization, or in the metric you can say events created, run query, and you can see everything in your Grafana. So most of the companies has these kind of tools. They have Grafana kind of dashboards. So if you can take your data from Flower to Prometheus or any other time series DB, you can get a good GUI based representation, which is not possible in Flower. Okay, make sense? Was it useful? Because if you are creating a production level system, you need to make use of at least a time series database, bare minimum Prometheus, if not Grafana.
Is there a directory in the GitHub for chapter 8? I don't see it there.
Yeah, because there was no code in it. So these instructions are there. So I'll share this with in the same folder, PDF files.
Just for like use cases for Grafana, what are some of the metrics you would track in a production setting for architecture like this?
So basically two things: number of events received, how much time it took. So in the time series, we can see on an average, if an event took, let's say 3 to 5 seconds, for example, or calculation intensive tasks. So if there is a deviation, we'll be able to see it in Grafana immediately. Okay. So it's also good for, in Grafana you can generate alerts. You can set up your alerts for a threshold value. You'll get a notification whenever your threshold value is passed. So preemptive kind of maintenance you can do. You can create one more instance of Celery, or you can do something else. But it's really useful to set up your alerts based on the event you are tracking. Two things you are going to track: time it took and number of events received. So everything is linked with Flower. Flower is linked to Celery, Prometheus is linked to Flower, and Grafana is linked to Prometheus.
Is there a way to run Celery without it being invoked from the directory that the code exists in?
It has to be invoked from the place where your main module is. So you can have your modules spread over, but you have to instantiate. You have to give the name of the module, and it looks into the current directory by default.
So if you have multiple projects, you have multiple Celery locations.
Not that. One Celery project is one project. You can have multiple copy of same project in different nodes. So right now, our task one right now, I can create a task one here, one task one here, right? So they will be linked together via the RabbitMQ. They will realize from the RabbitMQ, oh, there is another node running. So when we looked into the inspect queues, you saw one node online, right? this one. Okay, no node is there right now. I just had one node and I killed it. So there is no node. So if I run it from other place, you can see one node online. Because as of now only one node is here. So same Celery, if I am running from multiple nodes, it will automatically detect how many nodes where Celery is running, and it will say that many nodes online. So one Celery project, your one implementation, one set of tasks is a separate project on its own. If you are creating two different projects, you can, but then it will be like some tasks are available in one project, some tasks are available in different projects. Then the queue management is going to create a problem. There is a possibility of having a Celery updated version being start on a different node, and slowly you can close this. So it's kind of backward compatible way, blue-green strategy, you can apply in that way. But one project, one Celery. It's just that multiple instances of Celery is running on multiple nodes. Very good question. I am calling this task 1 as a project right now. So basically it's the same set of Python codes will be running in all the nodes. So that's one project. Same set of tasks. If you are having 10 tasks in Celery, so these 10 tasks is as a project, one project, and same instance should be running on multiple nodes to have a distributed kind of behavior. And everything is linked via RabbitMQ. The Celery implementation is such that if I'm running two instances, one here, I don't need to do anything. Like if all of us, right, if there is only one RabbitMQ, if all of us are running Celery, all of us become node for that RabbitMQ, and Celery will automatically determine there are 30 or 40 people out there, 40 nodes out there, and it will distribute the node to one system, different systems. So in that way, Celery is very easy because you don't need to do infrastructure setup. The same command I am using here to instantiate, I'll use the same command, multiple nodes, it will work. Okay? Did I answer your question, sir?
Yeah, I have another question. Do any of the tools that you showed us today have the ability to do any sort of resource management, the way like HP Contour, you can do HP Contour, is the way that does?
No. Okay, because in Celery the workers are not created by us. The workers are created internally. So we have limited control on, we can control how many workers, but how workers will behave, we have limited control on that. But while implementing the task, we know that each task will run on a worker. We can decide how much memory or CPU we want to use from each task. That we can decide. We can say that, okay, if I am using something which is taking more time, I can fork it and put it back into the queue for to be processed by something else. That you can do.
You do that through RabbitMQ?
Not from RabbitMQ, from your code. You can decide, I want to split this task so that there are two distinct tasks in the RabbitMQ queue, so that the resources are limited when the task is executed. Just similar to just consider MapReduce, right? We divide the tasks, right? Because one node is not sufficient to handle all the data. So one set of data will go to one task, another set of data will go to another task. In the MapReduce or Hadoop, you manually trigger those MapReduce. In here, you just need to say that one task, this much work will be done, it will automatically behave like MapReduce. Okay.
I had a question on the chaining. So you give an example of some A depends on B. Is it possible to share information between the functions? There's some result of A I can pass on to B.
You can do that. So one is chaining. Second is that once you get the result, you invoke another task with that result. in that way.
Did you do the Prometheus without the flower? You have to run flower to get the data to go to Prometheus?
Yes.
Could you show the command to run flower again?
And you'll upload the documentation to GitHub afterwards?
Yes, sure, all of them. So Prometheus, I guess you'll have to use if you're using it in production.
I didn't want to set up a web server on this.
So you can write code in the Prometheus format in your Celery task, and you can send it to Prometheus. But that will be needed only when you are not getting a specific information from Flower which you need. Okay, because Prometheus takes it in a format, and this will give it to us.
So is flower a separate process from the worker, I guess?
Yes.
Flower is not an option, okay.
So it just a separate, creates a separate web-based, front end for you. Okay. Yeah. Okay, this is clear. Okay, so let's go to the chapter 9, using Redis. So I talked about two message brokers which is predominantly used. One is RabbitMQ, second is Redis. So Redis is much of a, it's a cache database, and I can say that it's a full-fledged database, and it has much more functionality than RabbitMQ. In fact, in Redis, using Redis as a message queue is a kind of just using 5 to 10% of the Redis. Okay, because predominantly used as a cache database, cache store. Okay, so if you are using Redis already, maybe it's a good idea to make use of this Redis for message broker. Okay, then you do not need to maintain two separate cluster, and many organizations use Redis right now, so you can make use of it. Otherwise, RabbitMQ is good enough, but RabbitMQ is just queue, nothing else. Redis is more than a queue. One of the advantage I see over Redis is that I can also save my states in Redis. Okay, I can connect to Redis and save my states along with using it as a message broker. So again, based on your problem statement, you can define. But if you are using Redis, you will end up using more than just a message broker. I don't know anyone who has just used Redis only for message broker, apart from just for learning perspective. Okay, so I can show you an example of Redis. I can run a Docker container. You can use this to run a Docker container of Redis. Let me stop RabbitMQ. Okay. Actually, I've shared this document with all of you. This was there. Okay, so Redis is running on my system. You can do a ping, and you'll get a pong. So here is how you change your code for Redis. So in the Celery, we used the broker and backend as RPC, broker as PyMQP, which is RabbitMQ, you just need to change your backend and broker. Nothing else you need to change. Nothing else. Okay, and it will work as it was working for RabbitMQ. So let's run one of these. Okay, so chapter 9.1, let's run it. So we will be running it the way we were running it. Changing of broker doesn't change anything in the Celery. Okay, don't need to do anything. And this flower is complaining because stopped RabbitMQ. And if I go ahead and run this entry point, you should get the printout as you were getting it earlier. Okay. So you can see the first, second, and third, queues are created. Redis does, something more than that. Add some binding related information. It's not, something we should be worried about. It creates bit more, Celery in backend looks like creates bit more number of queues to handle the management of keys. But this should not be impacting anything. So if you are using Redis, you don't have to change, which means you can change from RabbitMQ to Redis without changing anything at your client side or your server side. Okay. Now let me show you one example which is not working with RabbitMQ, but will work with Redis. It's called chords. The chapter 5, the last one. So if chords are something which it's a kind of a function that gets executed once your normal set of functions are executed. I'll tell you an example. You are executing something like sending WhatsApp, sending SMS, and after it is done, you want to save a log saying that okay, these tasks are being done. Not being done, it's already done. Okay. So in these kind of scenarios, you can use chords. Okay. So basically, you can see I've created a group of 2 groups. So first group is I'm sending SMS and WhatsApp. Second group is total number of WhatsApp and SMS sent. So in the chords, I am giving first group, which will be like sending SMS, sending WhatsApp, and then status of that, what is the number of message sends, number of WhatsApp sent, and you can get the result by result.get. This functionality is not available in RabbitMQ. This is the only thing which doesn't works in RabbitMQ, but it works in Redis. Okay. So just as a last thing, let me run this. Okay. Can anyone is running Redis right now? No? Saying it's problem with default channel. Initial queues. Okay, maybe I'm using a different folder maybe. Yes. Sorry, I was using a different folder. You can see the result. The first group result is SMS and WhatsApp sent successfully, and number of SMS and WhatsApp sent. You can see it over here. So this particular functionality is not available in RabbitMQ. For this, if you want to use this, then you have to use Redis. There is no other option. Okay. Okay. Okay, so that's pretty much it I had for this tutorial. I hope it was useful to all of you. Thank you. Thank you.
Priority queues only work in RabbitMQ. Is that true?
It's a property of RabbitMQ.
Priority queues.
Yes, it's a property of RabbitMQ. So even you can create queues which can auto delete if it is empty for a longer time. That's also a property of RabbitMQ. Okay, so we can do these tweakings in RabbitMQ, but I don't think that's necessary, because if you want to delete a queue because you have created new queues, you can manually go and delete the queue in RabbitMQ. Don't need to write a code for that which will keep on checking and doing that. So
Just priorities, like priority 1, priority 2, like high priority traffic, low priority traffic.
but in case of Celery, if you define the queue, the task will go to that queue only. So in that sense, even if you define the priority, may not be of any use. So guys, I'll be here in the conference. So if you have any other questions, if you have some pending questions, feel free. I'll be here to answer. Thank you, all of you. Thank you very much. Thank you for your patience. Thank you. Thank you.